Hello, everyone, and thank you for joining us today. We are very excited to connect with you, our valued customers and partners, an insightful session on network security and performance. At Interlink, we're committed to building strong relationships with you while delivering cutting-edge solutions that keep your networks fast, secure, and resilient. Today, we have a special segment featuring our joint venture partner RioRey, where the expert Dean will dive into DDoS protection with BGP Flowspec, a powerful tool for mitigating attacks in real time. This is a great opportunity to gain valuable insights and ask questions directly to industry experts. Stay tuned, engage with us in the chat. My name is Christian, and let's get it started. All right. So first of all, we would like to discuss the agenda and show you what we have for you today. We're going to discuss, again, the latest and future POP additions of our network, which is growing not only in the European Union, but also very, very soon in a different market. We're going to discuss as well the products that we have launched lately with you for you and show it in the portal. And this time it is Flex Detect. So more to come on this one. Then we have Dean from RioRey here, who's going to talk about the limitations and use cases for using BGP Flowspec and therefore how to protect your network against DDoS attacks. And then this is followed by a Q&A session together with Interlink, but also our joint venture partner, RioRey. So just to remember you guys, what we are doing as Interlink, we have a very strong focused product set of IP services, Flex Ethernet, which is our layer 2 solution, and DDoS protection as well. We are currently focusing on the European market with also presence in the US, and it's going to be connected very soon to our backbone, but that's some information I'm going to share a little bit more in detail in a bit. So about the latest and future POP editions. You have seen the slide maybe in the last webinar already. Very good news. The hardware has arrived to both new locations in Sofia as well as in Thessaloniki. The out-of-band is already connected, so I expect those POPs to be live very soon. The same is the case for Stockholm. If you remember, we have planned for some time, actually, for various reasons, to change our network hub in Sweden from Equinix SK2 over to Digital Realty. All customers have been informed very early about this, so there's a change ongoing, and services will be available for some time in both locations. News products. And I'm quite happy that I can share something to you today because we have launched a new product in our portal, which can be provisioned automatically without any network engineers involved, as you know it from Interlink. So why did we launch this new product, which we call Flex Detect? It is a product which bridges the gap between IP transit and DDoS protection. There are a lot of our customers who do have a DDoS protection solution from us, but they have to do their own detection. There are various ways to do this. We have something for exactly these customers and found a way to make this available to our customers because we see the demand of our customers in the market. So a DDoS detection itself. So for who is this? This is for all Interlink customers. Dean, could you go on mute? Sorry to interrupt here. That would be amazing.
Thank you very much. Sorry.
No worries. So for who is this? It is for all Interlink customers who have already IP services from us. So it is the technology which needs to be added. So basically an IP service. This could be done also with a port which is free of charge at the moment for new customers without any bandwidth committed to this port, and the Flex Detect feature as well. So basically you have two options, or if you're already an existing customer of us with IP services, this is an add-on and you can have it from us, or you can, as a new customer, choose a free port which we call Flex Suite. This can be a 1, 10, or 25 gig port without any committed bandwidth, plus the Flex Detect product. However, of course, it is better if we do see some traffic on this port. Otherwise, the detection, is a little bit difficult to actually work properly. And very important to understand for you guys, it is no rerouting and DDoS protection functionalities included there. So it is basically only the detection of a DDoS attack, no additional services whatsoever. So if we go to the next slide, I'm going to show you where to find this. So this is the portal. I think you know this. This is the landing page. And if you want to add this service, you just normally hit the button add a service. You see all our products which are there, nothing changed apart from the actually Flex Detect product. So you know this slide. You can choose between Plus, Premium, and Enterprise for the DDoS protection service and choose additional networks that you would like to protect. And then in addition, there's the Flex Detect product, which we have priced around 200 euros, and which is giving you basically the full access to our DDoS protection mitigation platform, which we have built on RioRey hardware solution. But as already said, this is something which is not triggering any DDoS protection, but is only detecting a DDoS attack. So we have a proposal for you. If you're interested as an existing IP transit service using from us, you can have this as a trial. Yeah, you can be the first to actually use this product and have the chance to connect with our product team and discuss your feedback. If you are looking forward to do so, and it can be both options. Maybe you're already using IP from us, or you are a customer or a prospect who doesn't have any port with us at the moment. Both is possible. Just reach out to us via sales@Inter.link, and then we are happy to set this up. We have a poll for you because it turned out in the last time that it is very important in terms of topic and very emerging. We have been attending CloudFest last week, and most of our discussions, a bigger percentage of this, was in general DDoS protection as a topic. So we would like to understand from you, what was your largest DDoS attack in terms of the volume that you have seen in your network? Feel free to give us an answer here. It is very interesting for us to understand, and according to that, maybe shape our product or have additional topics for upcoming webinars. Then at this time, I would like to hand over to Dean. Happy to hand this over to you. He's going to talk about the limitations and use case for using BGP Flowspec in order to protect your network against DDoS attacks. Dean.
All right, thank you. And sorry about being not muted there earlier. All right. So yeah, as he said, I'm Dean with RioRey. We are the partners in the DDoS mitigation and their joint venture scrubbing center. For those who aren't familiar with us, we have focused since 2006 only on DDoS mitigation. So we're quite experts in it, and we've helped a lot of customers build their own off-ramp scrubbing. And so we have, I think, good perspective on helpful tools, even outside of our own product suite, of what's helpful for you when you're trying to deploy some sort of DDoS mitigation on your network, whether it's existing tools or through Inter.link or through a third-party solution or something like that. Well, Christian, you want to go ahead and flip, or do I flip the slides? Okay. So the objective here is just to the last webinar. If you participated in that one, you saw one of the Inter.link engineers talk a little bit about how you can implement BGP Flowspec in your network. And it's a really helpful tool. But I think this talk, we want to build on that and kind of take it to the next step in a little more detail about exactly when it is helpful and when it isn't, because there are definitely some scenarios where it can fall a little bit flat. It certainly has limitations, but if used in the proper ways, it can be a really powerful tool. All right, next slide. Okay, BGP Flowspec. So essentially, this is a quick little overview of it, things you already know. Really, at its core, Flowspec is a matching tool, right? That can allow you to set certain rules and identify packets on a source destination IP, destination port, the packet type, the flags, packet length, right? It's a pretty basic matching tool, and functionally, this is important. It takes advantage of existing resources you already have in your network, right? Namely your router, and specific for most vendors, it's specifically using the ASICs on the network interface card itself, and that's a really important distinction. So you're essentially going to add rules onto existing NICs that are doing another job, but you're kind of using them for two purposes. Next slide, please. Okay, so there are these capabilities, but what does that amount to? What actions can you effectively take with BGP Flowspec? So one, traffic redirection is a really obvious one. It's a really good tool by which to set certain very general rules that dictate when you would be suspicious of attack traffic might be present within your normal traffic, and then you can redirect to Inter.link Scrubbing Center, or you can take some other action with the packets. You can also drop packets with based on the rule matching. This is, as we'll discuss later, it's a little bit more of a blunt tool, I would say, but you can drop packets with BGP Flowspec. You can also do some rate limiting as well. We'll talk about some when you would and might not want to use both of those two latter features of BGP Flowspec. So if you could give me the next slide, Christian. Okay, so I think the number one reason most people are attracted to BGP Flowspec is because it's, to put it bluntly, it's cheap scalability, right? You have things in your network that are already doing a job for you. You've already paid for them. Can you use them to also mitigate DDoS attacks, right? That's the attraction. And you can also oftentimes use BGP communities or Flowspec communities on your upstreams and push rules to them. So it's an attractive thing because you're not having to purchase anything else. And some rules can be effective, and it can be effective in that way. The second part is it's really sort of a brute force tool, right? Depending on your goals for your network, sometimes you need to just save your network or just chop large volumes of traffic off upstream or at the edge to preserve downstream service. Even if that impacts the victim customer itself, it's saving your network overall, right? Sometimes, as it says there, sometimes good enough is good enough. Sometimes an inexpensive customer isn't worth putting sophisticated mitigation in front of, because sophisticated mitigation has a cost. So you can null route, you can do rate limiting, things that will impact them, but you save the rest of your network. And then, of course, traffic redirection, as we talked about. It's a really great tool for identifying when you should be suspicious of traffic and then redirect it to a scrubbing center, or like Christian was talking about, the new Inter.link tool, right? Using similar principles of identifying when you may or may not have an attack, and then you can take an action, whatever that action may be. So next slide, please. So when you are implementing BGP Flowspec, vendor-specific limitations. So BGP Flowspec is standardized, but it's not universally, how it's implemented isn't universally the same across all vendors, right? So if you have an environment with multiple vendors, or even multiple, even if it's the same vendor for routers, you can have different software releases running on different models running on different models at different data centers, and the way that BGP Flowspec is implemented on each of those might be different. And this can sort of yield a challenge if you're trying to do flow-based filtering on at your edge and trying to create rules that do a sophisticated job of dealing with DDoS. If you're trying to create a general policy that says, when I experience this, I'm pushing these rules out to my edge routers and it will stop attacks or do some action for me. That may not be universally possible across all your edge routers to be done in the same way. So it's something that our customers often run into, unfortunately, in the real world, where they create a set of rules, the rules are correctly defined, and they try and push them out to routers, and they won't apply correctly across every single router from every single vendor or every single model, or even every single software release within the same vendor and the same product model. So it's definitely something that you should be mindful of when you are trying to implement something like this on it. The other part of it is the limited number of simultaneous rules, and there's kind of two different aspects of this that can come into play. One, if it's your own routers, or two, if it's upstreams. If you're trying to push rules, available communities that your upstreams may provide you that allow you to push BGP Flowspec rules to them, right? Limitations can be very different. If you own the equipment itself may just have a set number of rules that can be applied on that equipment itself. And it may be up to 1,000, maybe a couple thousand, depending. So it can be quite a lot. Your upstream has similar equipment. You're sharing a portion of that equipment with a lot of other people. So you may only have 5 or 10 or 2 rules that you can apply. So you have to be really strategic about understanding what your options are when trying to create a regime of rules that you can use to mitigate attacks. The other part is, it's not just volume of rules, it's complexity of the rules. You are putting rules, essentially they're being pushed to run on the NICs in your network, right? And those NICs are ASIC based, and they have a certain amount of resources. And when you start to, even before you use up all those resources, they can start to sort of choke. They need a certain amount of overhead to continue, resource overhead to continue to forward packets at line rate. And so if you are rapidly trying to push rules or do complex rules on your routers, or as attackers pivot, make new and different rules and layer them on top of each other, you can end up in a situation where even though the rules are correct and what you're doing in principle is correct, you're actually running out of resources on the network interface card, and therefore the card will sort of choke and you can run out. You'll no longer be forwarding packets at line rate, and you can have some service interruptions on that basis alone, even though in principle your action should have been helpful. Christian, the next slide. Okay, operational limitations. So I mentioned before the operational challenges if you want to have a rule regime that you are using to mitigate DDoS attacks, and you have multiple vendors, different hardware, different software versions on the hardware in your network. That can be a difficult operational challenge to overcome, and it adds to your own sort of manual overhead when creating these rules. There are cases where BGP Flowspec, as it says there, you may need to disable certain other features that are resource intensive and able to implement BGP Flowspec. This can be the case with IPv6 specific features. So if you're looking at implementing BGP Flowspec, anything more complex than simply maybe detecting suspicious traffic and then issuing redirection to a scrubbing center or a scrubbing resource, if you're trying to do complex rule-based blocking, be very careful and make sure that you don't have to disable other things that are important to you, especially within IPv6. The other thing too is when you try to do more sophisticated things with Flowspec, you can have non-obvious, there's interdependencies can exist within certain rules, or they can step on each other, and unusual things can happen, and it can be very difficult to debug what exactly is happening. I think one example I have is when you announce a new BGP rule that causes a previous rule to become ineffective on a system, and maybe that previous rule is not actually related to your current DDoS challenge, so it breaks something else downstream. So the more complexity you try to apply within BGP Flowspec, the more likely it is that these sort of challenges will be run into. And then, of course, there's very limited visibility, right? There's not really reporting about what's happening, what's being blocked. which rule is actually causing you problems, or which rules are resource intensive, that if you're running out of resources on your router and you need to delete a couple rules, how do you quickly make that decision as from an operational perspective? You gotta balance which one you think is critical to you, but the one that's critical may be the one that is chewing up most of your resources. So it becomes very difficult to understand how to prioritize all these BGP Flowspec rules. Next slide, please. So this leads into kind of the biggest downside, even with like well-crafted BGP Flowspec rules. It's the matching criteria is relatively simplistic, right? It's rule-based blocking. It's not looking at, like, layer 7 attacks are going to be a huge weakness. You're not really going to be identify or take action against layer 7 attacks. The packet metadata is all you can look at. So for certain floods, you can't look at any of the packet content. This is where, more sophisticated, intelligent filtering really has an advantage over BGP Flowspec. And the net result is, on these first two bullet points, you can do matching and blocking on that basis, but the result is you're not going to be able to make very precise decisions about what an attack packet is and what a good packet is within the same traffic. It's going to be blocking inevitably is going to block both good traffic and some bad traffic. You're going to have some collateral damage. The other part is the attackers can quickly pivot and move around and force you to have to adapt really quickly. Christian, the next slide, please. And let me know how I'm doing on time. There's sort of a lot in this subject, and I'm trying to run through it fast.
We're good. Perfect. Thank you.
Oh, okay, cool. Let's see here. So, kind of building on what I was saying on the last slide, you can do everything right. You can write the best possible rules that you're able to. You can even, some people buy third-party tools that analyze your flow data, and the tool's job is to, in real time, as attacks shift and change, build rules and push them out to your existing equipment. And the thought is, this is cheaper than using a DDoS mitigation service or having your own DDoS specialized hardware, right? It's just something that's intelligently building rules for you so you don't have to. And then while that can be helpful, you're still going to run into the same fundamental problem that rule-based blocking isn't very good. It can't make a surgical decision between legitimate packets and non-legitimate packets. The rule-based blocking is going to block everything beyond a certain threshold, right? So you're going to have collateral damage. I think this leads to, that sort of leads to a decision that you would have to make is that good enough for me? Or do I have important customers that their uptime is critical? I need to meet my SLA, and therefore maybe BGP Flowspec isn't the best idea for my network, and I need to do more sophisticated blocking. Again, best effort sort of DDoS protection is a perfect example. If you have a lot of very inexpensive customers or people using free services, or you're applying some free version of DDoS protection under best effort, then perhaps BGP Flowspec blocking could be good for you. But it's not something I would recommend as using as the basis of a paid for service or a sophisticated service or for high value customers. Next slide. Okay, so quick comparison to intelligent platforms. I don't want to make this a sales pitch, so we'll blast through this really quick. But intelligent filtering in general, and us at RioRey, we do a packet by packet analysis of what's going on. We look at things fundamentally different because we're not restricting ourselves to the information that's within flows or simple packet matching. We can do much more sophisticated methodologies of identifying what an attack packet is and what an attack packet isn't, and we can be much more sophisticated in how we remove and target the attack packets and leave legitimate packets. We have a slide that, because we aren't doing rule-based blocking and intuitive things, it's hard to describe. The next slide will kind of give a quick example of it. The other thing is scalability. You know, we've already talked about some of the scalability challenges when you're applying rules to a network interface card that already has a job, and that job is to push lots and lots of packets. You're asking it to do multiple things at once, and that can lead to choke points. With intelligent filtering is going to be dedicated filtering. It's going to be run on. It's going to be software hardware combination that is designed to do exactly that one job, and therefore you're not going to have these choke points, and you're going to be able to scale your ability to handle many simultaneous attacks, you know, thousands of simultaneous attacks to individual IPs. Each of those individual IPs may have 7 different attack types happening at the same time. Intelligent filtering, well-crafted intelligent filtering, can handle that. It's better suited for a true multi-tenant environment where you have many things going on and you can't be bothered with rules and potentially choking out critical resources. Also, the other part is we can look at payloads. We can do very complex analysis of packet relationships with the source and destination pairing, right? And then, of course, reporting and visibility. You know, intelligent filtering will tell you exactly what type of attack is coming through. Not just that you're seeing a really large volume of traffic coming through and we're going to rate limit it because it's now triggering your rules. Intelligent filtering will tell you, hey, is this an AT17? Is this an AT1 SYN flood? What type of an attack? Who is the victim? Here's the volume of it. Like the rich visibility that you can get within the Interlink portal is a big advantage. And it's also something, if you're offering a service to your customers and charging them money for DDoS mitigation, or trying to show that you are a high value service to them, having that reporting is an important tool of communication, so you can show them exactly what you did for them, and that they were receiving an attack that is X large and you blocked 99.4% of it, and this is what their traffic was like. Showing those successes, because ultimately intelligent DDoS should be pretty seamless. You shouldn't have to take a lot of action. It should do its job. The customer should never really notice that they were under attack, and therefore you don't sort of get credit for doing a good job. And so these communication tools, if you're looking to resell or justify your customers how good of a job you're doing for them, they're really, really, really important, right? Next slide, please. So this is a quick, when we say we don't do rule-based filtering and why rule-based filtering rule-based matching kind of falls short, this is a really quick way to show why sophisticated filtering is better. So essentially what we have these 2 panels, and these are basically the entire IPv4 space. On the first one, it's a 50,000 packet capture, normal network. There's no attack. And you can see certain parts of the IP space are completely empty, not utilized. Other parts, there's clustering because you have customers in a certain country, or even global customers. Certain parts of the world are not awake and active, right? There's a certain degree of randomness in there that is relatively expected. Now, if you take at the same node, if you take a 50,000 packet capture during a spoofed flood, it will look like what you see on the right. And that's, we call this our entropy test. We test for degrees of randomness. And you'll see that would fail any entropy test immediately, right? It fails the visual entropy test. You can see that the traffic is perfectly randomly distributed across the entire IPv4 space, right? Even to this day, this is what any botnet, any spoof flood attacker is going to do: use random number generators to generate their random source IPs for their floods, right? And so you can see that you have this thin layer of perfectly randomly generated spoofed packets coming into your network, but underneath it, you're going to still have the concentrations of legitimate traffic. And so what we do, so one, there's the test, say, are we suspicious? Is this a flood? Confirm yes or no. Yes, we can confirm that even visually here. 2, how do you block the bad traffic and leave the good traffic underneath? Rate limiting won't do it, right? We know that will impact the good traffic. It's just taking everything beyond a point. We have adapted digital signal processing techniques that have been around forever. They're tried and true. They just haven't been used in this way, in an intelligent way. And so you can treat the perfectly randomly generated source IPs for that flood, treat them as noise, and you can essentially remove that thin layer of noise from the legitimate packets concentrations that are on the left, or you view it as the signal in this instance. So it's the only thing I'll do that's sort of close to a sales pitch of RioRey. But I think it's a good, it really shows you how different rule-based blocking is from intelligent mitigation, intelligent identification and dropping of packets. Christian, you can flip to the next slide. So, it's, BGP Flowspec, there's a lot you can do with it. It's not all bad news. It's something that can be really useful to certain people, right? And so it's up to you, the network operator, or the client, to decide and make your own calculus, right? Sometimes network preservation is king, and quality of service can suffer for lesser important people, right? And so that may be a choice. In those instances, BGP Flowspec may be good enough. False positives are going to happen as a nature of using BGP Flowspec filtering, and sometimes that's okay based on who the victim is, right? And based on the alternative where your network may be down. And then another case where it can be helpful is when you're, as it says here, you're not providing DDoS protection as a service to your customers. And so therefore you're not concerned with executing a super high quality version. It's more just maintenance of your network. If you are trying to resell DDoS protection to your customers or provide it as a value-added service or charge something for it, then customers, you're going to run into the real-world situation where customers expect less interruption than BGP Flowspec filtering will provide to them. And they're going to expect more visibility into what you're identifying as attacks and blocking, and they're going to expect it to be more responsive. And there should be another bullet point here that should have been added to this that says, it's really excellent for using as remote detection or creating off-ramp scenarios in your network. So you could have, if you had intelligent filtering within your network at every ingress point, it gets expensive. So you could use NetFlow-based detection and have one single intelligent filtering instance or device in your network. And then now you've cut your costs by in a fourth. You monitor the edge, you only shift suspicious traffic through that on-premise filtering device and use your resources much more efficiently. And then likewise, you don't even have to invest in an on-premise device. You could use Inter.link, for instance, and redirect through scrubbing centers like Inter.link operates, like we operate with Inter.link, and leverage BGP Flowspec to automate that and make it efficient and tailor rules specifically to it. So it's a very useful tool, but I think we try and work hard to dispel the sometimes misconception that your network has a built-in perfectly good DDoS protection tool, and that if you had enough time and resources, you could do just as good a job as intelligent filtering, when in reality, there's a lot of things there are a lot of fundamental reasons that make it not possible, even with the most capable engineers, even with third-party tools generating rules. Yeah, it's a tool at your disposal, and we think the choices, we want educated customers to decide when it's best to utilize it. And I think that's all I have. I know I went long. I apologize for that.
Yeah, no worries, Dean. Thank you very much. For those who have to leave now, thank you very much for attending. We still have some time, so we can overrun in case we do have some questions. So Scott in the back end, my good partner in crime, are there any questions already?
One has just been added, and it says, what was the biggest DDoS attack in your network?
Well, fair question, since we have asked this question as well. So I can speak for Interlink. So I do not have the full picture of all-time DDoS attacks that ever happened in our network. However, I recently was aware of a DDoS attack which has reached 800 gig. So that was, I think, recently the biggest one. That was also related to a customer who has BGP Flowspec rules in their network. And yeah, I think one of the challenges there is to use them correctly. So that's about that question. That's on my part. Maybe Dean, you have more insights from your end customers that you provide with your hardware appliances.
Yeah, so we don't pull data from our customers. They own the appliances for OPSEC reasons, right? We're only in if they ask us in. So we don't see a lot. Occasionally, our customers will send us a screenshot and be like, "Wow, look at this! This is what we got this last." And I think I've saw within the last 6 months a 650 gig attack that someone had been hit with, distributed across a couple data centers, and it was. We can see it in the centralized management, but that's what I can recall in the last 6 months. I think the majority of attacks are probably for most customers between 1 and 20 gigs for regular ongoing nuisance attacks. With spikes now these days, I think 60 and 70 gig attacks are much more common than they were even 3-4 years ago. So I think the average attack size used to be quite small. It was just the large ones you'd hear about. But now I think average attack size seems to be going up as far as our customers are telling us.
Another
All right.
question has come
Yes.
through. Sorry, and this is for RioRey. And it says, what is the max packet per second you can mitigate?
So you can put our devices simultaneously, you can put them in parallel, so you can scale linearly with device. I think we have a VM that'll do 50 million packets per second of any mix of DDoS. We have our hardware RE100 per 100 gig interface is doing like 80 million packets per second of any mix of DDoS. That's a conservative number because we do say any mix of DDoS traffic, and there's many different types. So yeah, our stated line rate is 80 million PPS, but you can put those in parallel and achieve essentially infinite PPS if you like.
Cool. Yeah, Scott, Dean, I would like to close the Q&A session now since we have been overrunning already a little bit.
Yeah, sorry.
Just so everybody who is attending now, we are actually focusing more on this topic. So the session that Dean was providing is perfectly blending in the next topic that we are going to provide to our audience. So we are going to have a session from Stefan Funke, who's our head of network and infrastructure, who's going to demonstrate a actual Flowspec feature if you acquire it from us as a service. So really looking forward to this one. Thank you so much for attending, everybody, and I hope this was useful. Dean, thank you especially to you, and have a great weekend, everybody. Bye bye.